You look at this problem and you think, wow, this is really complicated. The thing that Dr. Cho tells you to do is when you have a big complicated problem, focus on a little problem. If you could do the little problem, then build up to the bigger problem, because all a big problem is partitioning it into a little problem. Looking at the entire problem, what is it? I'm setting up two distribution centers. And what I'm trying to do is place them in such a way that when I look at all these restaurants, that the distance is going to be minimized. The guy who's in charge of all this is pizzeria. Get it? Pizzeria? Anyway, instead of looking at all these locations, and these locations are given to us, let's just focus on one. Let's focus on this guy here. So what am I interested in? I've got two distribution centers. I'm just going to arbitrarily place them. So these two distribution centers locations are going to be coordinates, and the entire problem is about distance. And so we know distance, or Cartesian coordinates, is just the difference in x's squared minus the difference in y squared and the square root of the entire thing. Let's just focus on this one point. Okay, what's the distance from the first distribution center with this point? Well, I can calculate it out, and it comes out to this, and you can see the equation up there. Distance 2, meaning this location, is going to be this distance. What I'm interested in is, what is the minimum of these two? Because that's going to define what the distance is to the nearest distribution center. That's it. I can do it for this. Now, I repeat it for the next one. So, 211, which is up here. So I do it again, and I do it again, and I do it again. Now I can think about my solver. And my solver is, again, three parts. First part, objective function. The objective function is, what's the total distance? I'm trying to minimize the distance to keep them close. So it's the minimum of the sum of all these distances. Next thing I want to do is, what variables am I going to fool around with? Well, I'm going to have solver figure out the coordinates where I need to place these two distribution centers. That's the hardest thing about this problem to understand. The third part, number 3, is about constraints. And we know from constraints, the x's have to be within the grid, so it's got to be less than 20 or greater than 0. The y's got to be less than 16 or greater than 0. And these values need to be integers. They need to be on blocks. That's it. That's the problem. Now, if you have problems in solver, meaning the linear simplex method doesn't work, then use the nonlinear model. Sometimes this thing has problems converging. Anyway, that's how you do the problem. If you have any questions, just let me know.